Okay, quadratic and higher order polynomials. We're going to start talking about operations with polynomials. When you're adding polynomials, all you need to do is combine like terms, right? That's all that is. Adding polynomials is simply combining like terms. So I take these guys, 3 and 8 is 11x squared. 2x has no friends, so it's just plus 2x, and then negative 5 and 2 here. These guys are like terms, so then that's minus 3. Now, you're probably going to have a fraction one on the regents, right? And you know how to add and subtract fractions. In the interest of time, I did a simple one. Remember, these are basic overviews. Subtracting, I need to keep, change, change. And what does that mean? Well, that means keep the first one, 5x squared plus 3x minus 3, and then change this to addition, and then change the sign of everything after it, right? Well, there we go. I pretty much just changed it right there above it. So now I combine 5x squared and then negative 3x squared. I get 2x squared. 2x and 3x is plus 5x minus 3. The most common mistake is people will just subtract the 3x squared, unless it's written with the parentheses. You know, the typical question is, I think the one we had on the regents was, if 3x squared minus 2x is subtracted from 5x squared plus 3x minus 3. Multiplying, you really just need to distribute. And if it's a monomial times anything, you just use the distributive property. If it is a binomial times a binomial, you FOIL or double distribute. If you have like a binomial times a trinomial, well, you distribute one through all three, and then you distribute the second term through all three. Okay, just repeated use of the distributive property. 3 times 1/3 is 1, x cubed, y to the 4th. And remember, properties of exponents here, when you're multiplying like bases, you add the exponents. And then that's going to be minus 6, x to the 4th, y. X to the 4th, y. Yep, there we go. Okay, next, moving on. Dividing by monomials. All right, and this is kind of a special one here if you just have a monomial. What you want to do is you want to divide each term. Okay? You want to divide each term. You want to kind of split it up and treat each one. So it's going to be like 6x, and then the y squareds cancel. And then plus 3, and then the x squareds will cancel, and it'll leave me y squared, and then minus 2, and then you're going to get like x squared. Okay, a lot of times when you have these monomials, you're going to have negative exponents that will result, or you'll have things that will be left in the denominator. Okay, so just be kind of aware of that. Dividing polynomials, all right, and this is really just simplifying algebraic fractions. We're going to factor them cancel, okay? I'm not doing long division with the Algebra 2 trig. It will be in the new Common Core. But. Okay, so I factor this. I factor this guy into x plus 2 and x minus 2. And that is the difference of two perfect squares. That's the first type of factoring that I'm going to review today, right? Second type I'm going to review is the first thing you should always look for is a GCF. 3x plus 6, the GCF is 3, and then times x plus 2. Okay? And then my favorite part here, right? This is my favorite part. This is cross those out, right? You can cancel any common factor in a numerator and a denominator as long as they're factors, okay? Just remember, don't be a home wrecker. Don't break up a family, okay? You've got to factor first and then cancel. You can't cancel terms. All right, algebraic fractions. Undefined. And undefined almost has the word under in it. I mean, it starts the same way. All right, so what's going on under? Well, you cannot divide by 0. And that's really kind of what you have to keep in mind here. So I'm not really too concerned with what the numerator is. I'm looking for what values of x is this expression undefined. That's going to happen when x squared minus 25 is equal to 0. And that's going to be x plus 5, x minus 5. Factor each one of those, and I can solve that. And then that's quite obvious from inspection that like negative 5 is going to cause it to be undefined, and so is positive 5. Okay, there we go, simplifying. Again, simplifying is factor cancel. I'm deciding to take this opportunity here to talk about the special case of when you have a minus b over b minus a. Now, these do cancel, but they don't cancel exactly. It's like 1 and negative 1, remember, because it's a minus b over b minus a. That only works with subtraction, and they have to be exactly the same term. A, and B, okay? You just have to kind of switch the order. All right, so when I factor this first one again, here's another GCF, 4, 2 minus x, and then in the denominator, this is a product sum. So I want the two things that'll multiply to give me x squared, two things that'll multiply to give me 4, and add up to negative 4. So I got to be negative 2 and negative 2. All right, and you can see here I can cancel that and cancel that, and that's a negative 1. So my final answer is going to be negative 4 over x minus 2. Another way you might see this as a multiple choice is they won't necessarily have that choice. What they'll have instead is they'll keep the negative in the denominator, and they'll have a 4 over 2 minus x. If it was multiple choice, that quite frequently would be the answer. If you're doing it like on your own without having to pick a choice, the first one I came up with is certainly adequate. All right, multiplying. What you want to do is factor and cancel. Okay, oops, factor and cancel. And that is any top with any bottom. I could cancel up and down, I can cancel diagonally, okay? It's just any top with any bottom. That's the difference of two perfect squares. This one here, that one's hard to factor because that's like a decimal check. I'm going to leave that for a second, all right? And I look up here, I see a GCF. Okay, so now I've got a hint. I've got a context clue here. Maybe this is going to be, one of these factors is going to be 2x minus 3, right? I'm going to try that, all right? Well, then that would obviously be x. Now, what do you multiply negative 3 by to get a positive 6? I think minus 2. Now I just have to check the outers and inners. 2x times negative 2 is negative 4x, and then plus negative 3x does give me my negative 7x. So there we go. I use the context clue to make factoring easier. All right, 2x minus 3's cancel. The x minus 2's cancel. Obviously, I can't factor a monomial. That's why I didn't bother with it. Okay? Now, at any time, if you think you've canceled anything, you can go ahead and now kind of put that together for x plus 2 over, and what's left down here in the bottom is 2x squared. I want you to stop and make sure now, double check, is there anything I missed? And hopefully you'll see, yeah, I could have canceled the 2 and reduced that to a 2. So it's 2 times x plus 2 all over x squared. And if you want to distribute there, you can, but you don't have to. Don't if you don't have to. Just invite yourself to make a silly mistake. All right, dividing, basically you're going to change to multiply, okay? And that is keep, change, flip. So I'm going to keep the first term and change to multiplication and flip the second one. So it's going to be something times something. All right, okay. Here we go, a 4-term polynomial. See, 1, 2, 3, 4. And that needs to be grouped, right? I group it, and then I factor the GCF. So here we go. This is another type of factoring we're reviewing. What's the GCF x cubed minus 2x squared? Well, it's x squared, right? That's going to be x squared times x minus 2. All right? And then when I look at this one, I have 3 for a GCF, and then I have an x minus 2. Now, when you notice, hopefully what you'll notice there is that that can be rewritten as x squared plus 3 times x minus 2. Basically, you're factoring an x minus 2 out of each one of those two terms, this term and that term, okay? X squared minus 4, I think we've done this one a lot already on this sheet. But again, you know, just in the interest of time, we'll do something that's relatively simple. Don't forget to flip this one. So this 2x squared plus 6 is going to go down here, all right? I'm going to factor a 2 out of that, because that's a GCF, and then I have x squared plus 3. Just look and make sure you can't factor that x squared plus 3 anymore, which you can't. It's got to be, if it's a binomial, it's either a GCF or the difference of two perfect squares. And then this one here, looks like I have a 16x squared in common. When I take that out, I wind up with like x plus 2. Okay, very good. And then my favorite part, this is the rewarding part. We did all that work, and now look at all the things that we can cancel. I love when a ton of things cancel. It's just very satisfying to me. So all I'm left with is really in the numerator, 8x squared over 1. Now, if I want to do this simplified, you know, I do need to divide that. 8x squared divided by 1 is just going to go ahead and be 8x squared. Okay. with complex fractions like this, remember, the way I teach this is to multiply everything by the LCD of all the little fractions. So the LCD of all the little fractions, I have 3, 3x, x, and 3. The least common denominator for all those is 3x. So I'm going to multiply every term by 3x. And these are all fractions, so I'm going to put these all over 1. All right, and the cool thing here is, all right, what cancels here? The 3's. What am I left with? X times 1, which is x. Okay, over here, the 3x cancels with 3x, and I get plus 1. On this one here, the x's cancel, and I get 3 times 1, which is 3. And here, the 3's cancel, and I get 1 times x, which is plus x. And then I look at that and see if I can factor or cancel anything more there, and I can't, so I'm done. Rational equations. When I have a fraction times a fraction, what I'm going to do here is I'm going to cross multiply. X minus 2 times x minus 7. I'm going to FOIL that. X squared minus 9x plus 14. Okay, good. This other side, I get x minus 3 times x plus 6, right? And when I FOIL that, I get x squared plus 3x minus 18. I'm going to subtract x squareds from both sides. So I subtract the x squared from both sides, they're gone. I'm going to add 9x to both sides. I'm going to get 14 equals 12x minus 18. And then I add 18 to both sides, and I get, I add 18 to both sides, and I get 32 equals 12x. And I get 32 over 12 equals x. All right, and just make sure you don't have an extraneous solution here. I can't divide by 0. 32 divided by 12, it comes out as a decimal. Neither one of those is going to be, it's not going to be 3 or 7, so that's my answer. Okay, you can, if you wanted to, you could reduce that to 16 over 6, and then 8 over 3, so it's 8/3, all right, is the reduced answer. If it asks for it in reduced simplest radical form, for example, it would have to be 8/3. Summary difference of fractions. So now this is a more complex rational equation where I'm going to go back to my other thing. Because I have an equation here, I can take and multiply everything, every single term, by x times x plus 2. And that's the equality property of multiplication. If I multiply both sides of an equation by the same thing, I do not change the value of the equation here, right? So here the x plus 2's will cancel, and I'm going to get 4x squared. For this one, the x's will cancel, and I'll get minus 12x minus 24 equals x squared plus 2x. Let's see, I got 3x squared minus 14x minus 24 equals 0. I'm going to leave it to you to figure out what that is. Okay, that's a guess and check perhaps. If it doesn't do guess and check, we're going to have to come into some of our other techniques for solving quadratics. All right, first one, factoring. It's the easiest, set it equal to 0 and factor. This one's already equal to 0, and then I just basically factor it. X and x looks like it's going to be plus 6 minus 2. So I'm going to get x equals negative 6 and x equals 2. Okay, that's that one. Incomplete quadratics. Now this is the one where you isolate the x squared term. So you get the weirdest looking thing alone, right? And then I divide both sides by 3, I get x squared equals 2. When I take the square root of both sides here though, remember that's going to give me a plus and minus radical 2. So I have two solutions there. All right, down here, completing the square. You have to write it in the form x squared plus bx equals c. So for this one, it's going to be 3x squared plus 9x equals negative 7. That's going to give me x squared plus 3x equals negative 7/3. And then the key to this here is going to be adding b over 2 squared. Well, b over 2 is going to be 3/2. And when I square that, I need to add 9/4 to both sides. So it's going to be 9/4 minus 7/3, all right? And then I add those. This guy becomes x plus 3/2 squared. The common denominator here is 12. 27/12 minus 28/12 gives me a negative 1/12. And then you take the square root of both sides. And we'll finish that tomorrow.